Alright, I'm striving to improve in neatness and quality of content. I want to show a little bit of what happens with the circle being proportionate to the square root of phi. And naturally your radius is always 0.5d. The square of this quadrant in the unit circle is the radius squared, and the area of the square is the square root of phi times the area of the circle. The area of the circle is 1 over the square root of phi times the area of the square. The arc at 90 degrees will always be 2 times the radius over the square root of phi. Some nice examples of how neat this makes everything. Where we have a radius at the square root of phi, it makes the area of the square at phi 1.6180339. The arc at 90 degrees equals 2.0 exactly, because you're talking about 2 times the square root of phi, 2r over the square root of phi, and 2 times the square root of phi over the square root of phi is 2.0 exactly. The area of the quadrant is the square root of phi. Now this is the only place where you'll find these two quantities to be identical, so don't let that throw you off. Here's another nice one where your quadrant area is 1. The area of the quadrant times the square root of phi is the area of the square, 1.2720196, and the square root of that number is 1.1278348, which gives you r, and 2 times r over the square root of phi is 1.7733035. That shows you the arc of 90 degrees. And this is back to the unit circle that everyone is familiar with, where the radius equals 1. Your quadrant area is 0.78615,378, which is just actually 4 over the square root of phi. 1 over the square root of phi. The area of square is 1.0. 1 times 1 is 1.0. Now 2 over the square root of phi will give you 1.5723027. And I hope you can bear with me. When I turn the camera on, my brain turns off, but I'm getting better. And thank you very much.